Hello, how are we doing? Welcome back. This is Grace again for video 1.4. What are we gonna do today? We're gonna take LFOs and we're gonna convert them to pitch in a more meaningful way. Last time we saw this example here where pitch was being modulated continuously by an LFO. This is fantastic. There are all kinds of sounds to be made here. You can make an 808 sound by continuously modulating frequency. But when we talk about pitch, we are talking about stepped frequency, right? The frequency remains more or less continuous. Maybe there's some vibrato or something like this, but there's a center frequency, which is consistent. We perceive this as pitch. So we're going to walk from the ccam.LFO into that, through that process. So we're going to show how to generate both MIDI data or MIDI, like translate that into a MIDI code, but also drive direct oscillators that take in frequency or hertz data. Just a point, I'm going to try and make this super quick. I'm changing things around as we go here. I'm excited to actually publish these ccam operators as a library, maybe as a package. When this is done, what I envision for this is that these will be a set of slightly higher level operators that are going to help people to program these Earth synthesizers that we've developed here at CCAM. And you can check out our website. We're going to continue saying more about that in the future. But on that note, I've changed a couple of things around. So I swapped the inlets, and so that this is basically consistent with phaser. If you send a click or a 1 in on the right side, it will reset the phase or reset the oscillator to its starting point. And then I've added a couple things as well. Last time I came into this like question of polarity, like if you popped up sine wave, it was like going between 0 and 1. So I added a function here so you can specify, oh, I want bipolar, which would be 2, or unipolar, which would be 1. And then instead of having this as an input, I made this wave into a param, just because like when I'm typing gen tilde ccam.LFO, I want to be able to say like at wave 2 and like get my sine wave like that. And then this final thing, I think this is also very important, is hertz. So hertz is still a param, but we're going to find that sometimes you want to dynamically drive the frequency of an LFO. You want to modulate the frequency of an LFO externally. So you can send in a frequency like a signal here, or you send in a frequency as a signal. And you'll see that as I change this, the frequency of the internal, in this case, rectangle wave, is being modulated. If this drops to 0, it will default back to what is set as the parameter that you type in, right? There's also a default, if you don't type anything, I think it'll come up as 2 hertz. Yeah, also a fun thing too is that you're able to invert these, which like probably is most useful in, I would say, triangle. That's also a parameter there. But we're going to go ahead and get into something different. I did want to just bookmark that though. So I'm going to imagine that we're starting somewhere here. And we may have, we're used to probably seeing a cycle object that's plugged in here. We can give it an argument, right? We saw that. Oops. We can give it an argument that's a frequency, and we can hear that. Or we have some kind of MIDI device. And this one is just a plug-in, standard, max for live MIDI device, like so. So what I want to do in this tutorial is I'm going to step through how to take a LFO and the signal coming out of that and basically slice up the intensity between 0 and 1. I want to take that and I want to cut it into little parts. And I want to say, this part I want to be one frequency, and this part I want to be another frequency, and this part another frequency. This is a kind of quantization or a discretization of a signal. And this is actually not super tricky to do. As we go through this, oops, that's not what I'm trying to pull up. Yeah, I guess we can save that. As we go through this, we're going to add in some other like bells and whistles that are going to start to make this sound more melodic, right? What we are thinking is that this contour here, this like can be a melodic contour. So how to introduce maybe more peaks and valleys, some randomization. We're going to look at that as we go. So first things first, I mentioned quantization. And I am going to pull up my... Okay, so we're going to start to write a little bit of code here. We'll take in this signal. And the first thing that we want to do is we want to multiply this by a number of steps, right? And so this is like the slices, or not quite the slices, but actually like, you know, the number of pieces of the pie or something like that that are left. There's the number of slices, and the count of pi is slightly different. So we're going to multiply our incoming signal that is a unipolar signal, goes between 0 and 1, by the number of steps. And here we can say param, steps, at min, probably 2, at max, I don't know, 32, something like this, and maybe at default. I don't know, 8 is good. And I've used this, I'm going to backtrack here. I use this variable. I actually want to make sure that this comes in as an integer because I don't want this to be multiplying by levels that are, you know, not an integer. So we're going to keep as kind of good practice here. I'll try and make this bigger for the screen record. I want us to see what's happening here. And let me open this inspector, and I'm going to change the range because actually we're going to take it higher. Let's see. So in 1, at steps, at min, at default, let's go ahead and it looks like maybe this is not reloaded entirely. I'm going to make this param here so that I can change it. One little thing that I'm doing all the time as a sidebar, when I've just made this param and then I've sent it into an integer to flatten it into an integer. This is not a floating point. The default always is that your attributes show up as this floating point. So I'm going to open up this attrui, this attribute UI. I'm going to go in here. I'm going to say, I want an integer, right? And that's just going to make it like easier for me. So when I open this up and I hit 8, hopefully I should be seeing some movement here. I don't quite see that. So let's see. Let's see what is going on under the, not under the hood, but coming out here. We have just a 0 there. That's, out 2. Oh my gosh, great. So let's make this out 1. Boom. Great. Okay, so now we see that this is moving between 0 and 8. We also want to use a round, and then we're going to get, this is basically the rest of the sauce here. Now we're getting these numbers. And so these numbers, these integers, we can think about as different scale degrees. So what's a scale degree? It's like a specific note in the scale relative to the tonic. So let's slow down our guy here. And actually already, we can go ahead and add to this a MIDI offset, like 60. And we can convert this to a number. And these are going to be in MIDI range. I could plug this in here, but I also am going to be just a reminder of how MIDI works, right? I hit this and it sends a note on, and then it sends a note off. When we are transcribing or transcoding between signals and MIDI, just notice this is coming constantly. This bang here or this and this number is coming at audio rate. So what we want to do is we can use change. No, I think we want to not change tilde, but change tilde, but change. What does this do? This filters out repetitions of a number. This will send a number if it changes. Great. Wow. This is not very loud also. This is like giving circus music a little bit, but they are MIDI notes, right? So now we do have pitch, which is static. We could also use the F to M object here, other way around, M to F, MIDI to frequency. And we could plug this into our cycle object. Right? So the difference between what we had in the last patch was that no longer is frequency moving continuously, it's moving between these steps, right? Cool. Hopefully that's all good. What's next? Well, probably we want this to not sound, probably like you may want to use a scale, right? There's a whole other discourse and course to be taught on scales and, sorry, I'm going to try not to talk over these things. There's a whole discourse around scales and microtones and so on. We're going to bracket that for now, just because this is kind of an opportunity to teach some fundamentals. You may want to use a scale. So there are a number of ways to do that. One way is like zl.lookup, and then you can plug your scale list in here. You can say 60, 62, 63, 65. So that's like a do, re, mi, like a minor, fa, like a minor scale, beginning of it, the first four. And then you have sol, which is your fifth. And then you could have you could have a flat sixth. Let's do a flat sixth. Lay, sol. And look, if you made it this far in the video, you get to hear me do some solfege. Now we have this lookup table here, and we could actually take the MIDI offset out and put this in through here. Boom, boom, boom. And let's hear that. Now we have a scale, right? But this is with Max. The reason that I want to show how to do this in Gen is that ultimately what I'm interested in is putting this code onto microcontrollers, which I'm going to use as performance hardware or installation hardware. And that uses this library called Daisy, or Oopsie rather, Oopsie. And that needs like just one Gen object. So like mentally, I'm thinking that I want to put this all in Gen. I'm going to introduce this CCAM simple steps to pitch. And before I write this, I need to remember that, topic to pitch. This is a Gen object. And I'm not going to go through, I think this is uppercase, like so. Yeah, so I'm not going to go through how all of this works. It's actually pretty straightforward, but it does use this code box here. basically what it does is it looks and sees if a number is very similar to the lookup table, right, that we just saw, or that ZL lookup. If that incoming number is 0, send out 0. If the incoming number is 1, map that to 2. And there's some other code here which extends this up an octave, or up many octaves. The other thing, and so let's just hear this actually. So outcoming here should be pitch hertz. So let me get rid of this and let's hear this. Great. We can also increase the number of steps. And this is still working, right? This is not going to be a pitch quantizer that you're going to want to use for every application, but it's pretty straightforward. The other thing that you can do here that I find helpful is that you can, they're basically Booleans here for the 7th. These are like the scale 7th, the scale 6th, the scale, 3rd. And this would be a way to, actually also all of these should be integers like so. Let's hear that again. I can change this to 1. And now we have a major third as opposed to a flat third. Now we hear that. Perhaps we have now a sharp 6th. And we could have now a full major scale by having a 7th, sharp 7th, right? And so you can, right, now you get a minor, and so on. So it's like kind of easy to parameterize that. Again, these are attributes. So you could just say 3rd, 1, 6th, flat, let's say 6th, yeah, flat, and 7th, flat. Actually, sorry, 6th sharp and 7th flat. We'll have like a Mixolydian moment here. Great. How do we get this to MIDI? Basically the same way as before. So what comes out of this here is going to be MIDI values. That's built into this. So we just need to use, is this using change? Oh no, yeah, we could do this like so. And, oh, we should be getting that coming through. What's up? Yes, good. Let me delete this. Oh, we don't need the MIDI lookup. Yeah, right, duh. So let's make change. We have to keep in mind our translation from audio rate. Great, fantastic. So that's it in a nutshell. I think I'm going to keep this there for now to keep this video a little bit short. When in the next installment, we're going to talk about wavefolding. So taking this LFO here and multiplying it and then taking just, it's like a really nice way to introduce some peaks and valleys in here. So we don't just have a da-da-da-da-da, like a do, re, mi, fa, sol, la, ti, do, and then back down these scalar moments. And we're also going to talk about how to introduce random jumps, right? And this can start to make more of a, an interesting melodic moment here. So yeah, that's all I'm going to say for now. I would encourage you, if you have this patch here, like experiment with changing the frequency of this LFO, changing the duty cycle. You can invert it now and change the number of steps as well. And so on. That's it. Stay tuned for next time. We're going to keep building in this patch here. And then ultimately that's going to be one of the examples in the intro to Microsound project. Thanks you all. See you next time.